Alright, here we are on homework with the quadratic formula. We'll start with homework problem number 6. It's one of your first ones, and it starts off pretty simple. I just want to reiterate that quadratic formula is just one way of getting to the right answer. It's just the one that will always work, and you can be confident it's always going to work. You could have just as easily on this one solved it by completing the square. You would say half of negative 16 is negative 8. This should be a 64. I need to add 57 to that in order to make that a perfect square. So I get x minus 8 squared equals 57. So x minus 8 is plus or minus the square root of 57. And then you would get x equals 8 plus or minus the square root of 57, something along those lines. But if you didn't want it, obviously it's not going to factor, and not factor to nice numbers since we did that. What you can do is apply the quadratic formula. Again, feel free to just have that next to you. Write it down at the top of your worksheet, or at the top of your homework. Have it on your card that you just took notes on, and just look at that for reference. Again, I'm not so worried about you having it memorized as being able to apply it. But the formula says, here's the step that I really do suggest, however, is take a moment to actually write what A is, what B is, and what C is. Now, I know a lot of times what I ask you to do seems tedious. However, I also see you guys making lots of mistakes that could have been avoided if you just did that one tedious step. So philosophically, ask yourself, which is more tedious? Writing down what A, B, and C are, or having to redo an entire problem because you didn't take a moment to write down A, B, and C? All right, I think in the long run, you save more time by staying organized. All right, if you look at the coefficient of x squared, there's no number there. But it's not 0 x squareds because I see an x squared. How many x squareds do I see? I see one of them. That means my A value is 1. It's important that we look at the signs. Our B number is not just 16. It's negative 16, and that's going to make a big difference if you don't get that correct. Finally, I have the value 7. That's a positive 7, so that's what we write there. Our formula says that we're going to do negative B, let's write the B there so I remember, plus or minus the square root of B squared minus 4 times A times C, all of that over 2 times A. Now I just have to insert those values into this formula. The B's were negative 16, that goes here and here. The A was 1, that goes here and here. C is the only thing that's in there once, it goes right here. Alright. Now I can rectify the entire equation. This is negative 16. If I take away a negative, that's the same as adding a positive. So I have 16 plus or minus the square root of 16 squared. The negative times the negative is going to be a positive. 16 squared, if you don't have that memorized, I teach computers, and powers of 2 are things that are instantly available to my brain. But if that's not you, use your calculator or take the time to do the math. 6 times 6 is 36. That makes a 9. 16, 256. All right, so that's 256 minus 4 times 1 times 7 is 28. All of that's over 2 times 1, which is 2. All right, now I have to condense this part. 56 minus 28, right, is 16 plus or minus the square root of 228 all over 2. Now, if you recall, when we did this one by completing the square really quickly in my head, there ended up with an 8 here. There is no fraction. I'm going to go ahead and bet that maybe 2 goes into this somehow too. That would only work if this reduces. Let's check it out. 228, I'm going to suspect that a 4 goes into that. Let's try it. 4 goes into 22 5 times, 2 left over, 7. This breaks down to 2 times 2. This one does actually break down again. It's 3 times 19. However, those are both prime, so they're going to just go back to that. These do get to come out, however. So our answer is 16 plus or minus 2 square roots of 57 all over 2. since the denominator, oh my gosh, am I off the page? Oh no, I'm not. Alright, since the denominator goes into both of these terms, we have to reduce it. It's not just that we can, it's that we have to. That makes that an 8, that makes that a 1. So our final answer is 8 plus or minus the square root of 57, which is what we got by completing the square. On the test, I don't care what test you're taking. If it says complete this by completing the square, solve this by factoring, solve this by using the quadratic formula, if you can do it a different way, like if it says solve by completing the square and you want to use the quadratic formula, more power to you. On tests, we're only worried about getting the right answer. But on your homework, go ahead and try it this way, because if you don't at least practice doing it each way, you won't know which one you're best at. Alright? It's kind of like maybe in practice you might practice a baseball swing 3 different ways to see what works best for you in practice. But come game time, you're going to stick with the one that worked out best for you. Right? You're not going to switch it up a lot during the game. You go with whatever you were best at. But you would never learn a better stance, a better swing, if you didn't practice a few other things. Right? Or maybe you can compare that to a serve, or to, I don't know what you do in soccer. The proper slide tackling formation. Something along those lines. Who knows? Alright, well, maybe you know, but I don't. Anyways, on to this problem here. We can't immediately determine what A, B, and C are until we have this set up in the quadratic equation, right? Quadratic equations are set equal to 0. This is not yet set equal to 0. Easy solution, however. All we have to do is get all of our terms with the s squared. So I'm both going to add 14 and add 3s to both sides, and then I'm going to write them in the correct order. These are going to cancel, these are going to cancel, so on the right, all I have left is 0. On the left, I have an s squared, I have a 3s, and I have a positive 14. It's important that you put them all on the same side so you don't mess your signs up. Now that I have that, A is 1, again, B is 3, and C is 14. Okay? I'm going to put that into my formula. My formula says that we go negative b, the b was 3, plus or minus the square root of b squared, again the b was 3, minus 4 times a times c. A is 1, c is 14. That's the only place that the c goes. All of that over 2a. One more time, a was 1. Now we just need to resolve all of that. That is negative 3 plus or minus the square root of 3 squared is 9, minus 4 times 1 times 14 is 56. I was going to say that sounds familiar, but we had the 256 in the last problem. That's why. All of that over 2, which is the same as negative 3 plus or minus the square root of 9 is barely above 0 compared to this negative 56. So we're going to go way negative on this one. It's going to be negative 47. Is that right? Yes. All over 2. 47 is a prime number. However, we need to deal with this negative. So we say negative 3 plus or minus I square roots of 47 over 2. And there's our answer. By the way, what does that answer represent? That answer represents the two places where this graph hits the x-axis, where their value is 0. If you looked at this parabola in its actual graph, you would notice that it does not hit the x-axis. Why? Because the two places where it hits are, in fact, imaginary. It tells us a little something about the graph. Alright. That was numbers 6 and 15. And now, have fun with your homework. Until next time.